almost exactly 60 years ago, the end of January in 1929, a sensational discovery was made at the Kaiser Wilhelm Institute in Berlin-Dahlem by Professor Bonhoeffer. Bonhoeffer was my advisor in my PhD thesis, which I started at the end of 1928. Now, how did it happen that I was at this place, at this momentous discovery? I was born in 1906 in a small Hungarian town. The name I don't dare to pronounce. It's called Dunaszerdahely in old Hungary. My father had a pharmacy there, but soon we moved to Nagyvárad, which is a fairly large town in the eastern part of Hungary. My brother Ladislav was 2 years older, and 3 years later we got another son, another brother, Paul. Our parents were wonderful. They wanted the best for us, the best schools and the best educations. We started grammar school, or my brother 2 years ahead of me, in a wonderful school run by the Jewish congregation. I can remember to this day all my elementary teachers, and for that matter, all my teachers in high school and at the university too. I think all my teachers were excellent. I was very lucky in this respect. In the elementary school, we started 3 languages, more or less. Of course, Hungarian, German, because of our association with Austria, and also a little Hebrew. 4 years later, I was transferred into the gymnasium, what I call the high school, run by a Catholic order that was originally founded in Prémontre in France. We had Latin from the 5th grade on to the 12th grade, so eight years of Latin. We had math from the 6th grade on. We had a wonderful math teacher and an excellent teacher of Hungarian and German. In the junior high, we started higher mathematics. We had differential and integral calculus. And by the time I got to the university, I was very well prepared. At the end of the First World War, a part of Hungary was ceded to Romania. That was a big change. We had to start to learn Romanian on top of the other 4 or 5 languages. At home, we had private lessons in French and English. So before we finished high school, we had to cope with 7 languages, more or less. Before I finished the gymnasium, the Romanian closed the school because of subversive activities. And this was a big problem, even though they cooperated with the authorities and taught us Romanian language. After some problems, we started in a gymnasium or a high school sponsored by the Jewish community, and our last high school year was spent in the Romanian high school. This was very difficult because they required more Romanian knowledge than we could master. But anyway, we settled. We got our certificate. My brother finished high school 2 years before me, and his great wish was to study in Berlin, Charlottenburg at a technical high school or a technical university. In 1922, my parents took him to Berlin. That was the height of the inflation. The money had no value. Every day the value went down to a tenth or even less every other week. And he entered the university in the fall of 1922. Unfortunately, he couldn't get a place in the chemistry department and had to study electrical engineering. He transferred to Vienna because he didn't like it, and started his chemistry career there in end of 1922. And this is how I happened to follow in his footsteps 2 years later and joined him in Vienna. Now, why didn't I study in Budapest or one of the Hungarian towns? The simple reason was that by then they introduced the numerus clausus, which didn't allow more than a small percentage of Jewish students. I completed my studies in Vienna with pretty good results in 1928. By that time, my brother has received his diploma at Charlottenburg. His master thesis was a technical paper on the formation of drops in supersaturated steam. He got this idea from a young assistant who took his degree a few years before him. His name was Leo Szilard.
Did you know Szilard?
I knew him. I met him. He was a most extraordinary person. He once, it was many years later. You know, the story goes that he loved to sit in a bathtub for a long time, and the best ideas came in the bath, sitting in the bath. One day, he tells the story, he was crossing a street in London. The light just turned green, and that turned on a light in his head. This was in the, must have been 1930 or 31. And the idea was that if you could promote a chain reaction in which a decaying atom produced one or more neutrons, more than one neutrons, I should say. For each neutron that caused decay, you could construct an atomic bomb that could destroy half the world. Of course, this was at that time a very fantastic idea, hardly anybody would believe that this sort of thing is possible. But Szilard kept harping on this, and once in the Cavendish laboratory he proposed this to Lord Rutherford, and he almost got thrown out. But eventually, as the history shows, he prevailed on, I think it was Wigner, who was also a friend of my brother, because this was a kind of a Hungarian colony at Charlottenburg. There, Szilard, Wigner, and also Johann von Neumann, the famous mathematician, were at Charlottenburg. Of course, later they changed their interest from chemical engineering to math. Now, to continue my story, my brother did very well at Charlottenburg, and he was recommended to Bonhoeffer, who was at the Kaiser Wilhelm Institute as a PhD candidate. And this is how my brother got into Kaiser Wilhelm Institute, through the recommendation of his professor, who was Professor Vollmer. You want to stop?
That's okay.
So my brother was at the Kaiser Wilhelm Institute in 1928, when I was ready to do graduate work. He was then the assistant of Professor Haber of world fame, who was the greatest authority at that time in Germany, and probably the whole world, in physical chemistry and applied physical chemistry. He was the inventor of the synthetic ammonia process, for which we got the Nobel Prize, I think, in 1918. And the institute was well endowed, had the most modern equipment and every possible facility, and excellent people like Polanyi, Kalman, and others who worked in different departments. So I started on my PhD thesis in 1928 on gold and silver hydride. I was supposed to show that at high temperature, gold and silver combine with hydrogen, which you can find by line in their spectrum. I was, when this great parahydrogen discovery was made, I was halfway through with this work. And by the time I finished, I asked Professor Bonhoeffer whether I could work on parahydrogen in some aspect. He said, sure, we have plenty of problems. And that's how I got into parahydrogen. First I did the thermal conversion, and then 2 years later, or rather 2 years later, Bonhoeffer was appointed professor at Frankfurt, in charge of an Institute for Physical Chemistry. And that's how I followed him to Frankfurt.
What was he doing that led him to discover the orthoparahydrogen?
Well, the importance of the work was connected with the new quantum theory, according to which not only light has wave character, but matter has it too. And conversely, radiation has a certain amount of corpuscular character. In other words, light behaves like matter to a certain extent, and matter behaves like radiation or waves. The theory was that at low temperature, there should be a conversion from one type of hydrogen in which the rotation has even numbers and the spin of the atoms anti-parallel. And the other type has even numbers, rotational numbers, and the two spins are parallel. Now, this doesn't happen immediately, but after maybe a year or 6 months or something like that. They waited long, and there was a few weeks, and there was a small amount of change in the proper direction. But the big discovery was that if you pass hydrogen at low temperature through charcoal, the conversion appears immediately, and the reaction is very easily shown. Now, this was then considered a proof of the new theory about the structure of the atom, or the molecules, and the thesis that the two different spins are connected with either even or odd rotational quantum numbers. Now, this discovery was a big sensation in those days, and everybody jumped on the bandwagon, tried to repeat the works, and all you needed is charcoal, and it was very simple to reproduce. Bonhoeffer was immediately invited for a lecture tour in the United States, and he was dined and wined like a great discoverer, which he was. Unfortunately, he and Hartek, who was his collaborator, never got the Nobel Prize, but probably because there were so many people involved in the development of the theory and elaborating before the actual proof was provided.
How did they decide to use charcoal?
Well, the way I remember it, one of them had the idea maybe there is some impurity in hydrogen that should be removed, a minor impurity. So they passed the hydrogen to charcoal, which would of course take out any organic or inorganic impurity rather than hydrogen. And then the conversion immediately happened without any effort, and that was the whole trick. Now, I did a lot of work at Frankfurt in about 2 years while I was there. I watched the laboratory building go up. Bonhoeffer got a brand new laboratory. I have some old pictures showing the excavation and the carts, horse-drawn carts carrying out the debris and so forth, and the building. It was a relatively small building, two stories, but very well equipped. Well, my honeymoon there didn't last very long, because then Hitler came to power in 1933. This was just 2 years after I got there, or rather, I think 3 years, 2 or 3 years. And it was obvious that you couldn't stay there. The students came in dressed up as stormtroopers, and it was impossible. So I left. I was told that this is going on all over the country, and there are many scientific refugees who mostly went to Paris, where they got this direction what to do or where to apply. No, my brother and the people at Haber himself thought, well, Haber is such a famous man. He was half Jewish and never professed to be of being a Jew, that he will be saved. But that was a big mistake. Before the year was over, he was out. Now, I should have mentioned that in 1932, this is another interesting point, there was a Faraday Society on absorption of gases and reaction of gases in absorption. And Bonhoeffer and I wrote a paper for this symposium. And in the last moment, Bonhoeffer couldn't go for some family reason and said, "You go." And I went. And this was a wonderful experience. I was very young, 26 years old. And I went to this international congress where they treated us like royalty. And I was a overseas visitor, they called. And for the overseas visitor, they had a wonderful reception and dinner party, and we were given a hotel room in the best and newest hotel, the Dorchester Hotel, where we stayed overnight, and next day we went to Oxford where the meeting was. So at this meeting I met Professor Riedel, and he was enthusiastic about parahydrogen, and he wanted to hear everything, and was apparently very impressed by my talk. Actually, it was a very brief talk, because in the Faraday Society, all the lectures or the papers are pre-printed and distributed for the registrant, so that the author only had to point out a few highlights of his presentation and invite some questions. And he almost immediately invited me. He says, why don't you write a book about parahydrogen? And there wasn't not much to write. I said, sure, I will write a book, whatever there is. And he said he is on the board of Cambridge University Press, and they have a physical chemistry series, and he's sure that he can persuade the syndics, they call them, the governing body, to accept this. Well, little did I know that within a year, from 1932, I would be a refugee and would find a home in Riedel's laboratory. So that's how I got to Riedel, you see. And here is the book, this, and I think I have the audition. It was published in 1934. Did you strike it?
I need to get it a little closer.
This was published in 1934, and it was considered a great book. But by that time, though, I'm a little ahead of the story, because by that time heavy hydrogen was discovered. And we did a lot of work on that subsequently, and eventually all that was included in this book. So it was twice the size, and it was not only on parahydrogen but also on heavy hydrogen. Well, what happened is in 1933 I started to work in the Professor Riedl's laboratory. He had actually no space for me in the laboratory, but he said, look, my office is on this at the top floor, which was like an attic really in the colloid science. And he said, but you can, there is a long bench, you can set up your equipment. Well, what I intended to do is use a method, a thermal conductivity method, which I developed for parahydrogen, to use for mixtures of orthoparahydrogen, also for heavy hydrogen. This was a little gadget that worked at about 1/1000th of a millimeter pressure and would need only less than a cubic millimeter of gas. So there, no, I don't know how to do it. Can you stop?
Go ahead and say something so I can check it.
The sun is out, and it seems that there won't be any rain today. While I was working in Bonhoeffer's laboratory in Frankfurt, my brother had several foreign graduate students or postgraduate students, and one of them was Wansboro Jones, a young man from Cambridge. He belonged to Trinity Hall, the same college that Riedl belonged to, and actually he was Riedl's right-hand man. The other student was Thomson. He was an Oxford man, and later I saw him in England. Now, my brother was supposed to measure the ignition limits of parahydrogen, and this they did by mixing parahydrogen, pure parahydrogen with oxygen, and measured, tried to determine the conditions under which such a mixture ignites. And they found that the mixture was absolutely not different from ordinary hydrogen and oxygen mixture. And repeated experiments showed the same result. So they had the brilliant idea to check whether the parahydrogen is still there. Now that's not such a simple thing to do, because you had to remove the oxygen first. But they did that by freezing out the oxygen in liquid hydrogen. And lo and behold, the parahydrogen wasn't there anymore. It was converted to ordinary hydrogen, and they discovered a very interesting phenomenon, that paramagnetic substances, oxygen, which is one of them, and metal ions convert parahydrogen. Now, this was around 1933 when Hitler came to power. And while I left Frankfurt before he left Dahlem, but before the year was out, he had to leave, and so had Haber. Even though Haber, everybody thought Haber, although he was only a part Jewish descent, would escape Nazi persecution, but it wasn't so. so I was only in Cambridge a few months when my brother appeared, and a few months later even Haber came. He was by then a broken man and very sick and could hardly talk and highly disappointed with things in Germany. Now, by that time, I had my work bench ready in Redil's loft or attic there, and my brother joined me. It was cramped, but we did some very interesting work about heavy hydrogen. We could use that microconductivity method very efficiently, and in a few weeks we cranked out a lot of results. In end of 1933, there was a symposium on heavy hydrogen, and organized by Lord Rutherford, who was very interested in heavy hydrogen because he intended to use it as a missile in bombarding other atoms. Previously he used protons, and now he wanted to use the deuterium nuclei, which were called deuteron. In the meantime, one of the collaborators of Bonhoeffer, his name was Hartek, who was the co-discoverer of parahydrogen, decided that he will study radioactive systems, because he heard a very interesting lecture by Lord Rutherford a few years before. And he got a fellowship, and suddenly we found, we had a reunion in Cambridge. Hartek, my brother, I, Wansborough Jones, and even Haber. Wansborough Jones was very kind to us, helped us in every way, and he helped me with the English in this book, which I was composing at that time. This was at the end of 1933. In 1934, my brother got an invitation to assume a professorship at the Hebrew University in physical chemistry in Jerusalem. They offered this job to Haber, but he was too old and really not able to do that kind of a job anymore. My brother joined the Hebrew University the following year, in 1935. At the end of 1934, Urey visited our laboratory, and he knew about our work and on heavy hydrogen, and he was very impressed by our use of this high microconductivity technique, and invited me, because my brother was already engaged in going to Jerusalem to visit the United States. Now this was a tremendous opportunity for me. In 1935, in April, I sailed for the United States, and I was really think I am in heaven when I arrived there. Urey waited for me at the dockside, and he had with him a young professor named Rabbi, R-A-B-I, a famous professor, but he wasn't a Nobel laureate. About 5 years later, he got a Nobel Prize too. And these eminent gentlemen received me at the dockside, and I waited for my luggage, and I had 2 suitcases, and they each grabbed one, and before I could say anything, they took me to his Yuri's car. And so it happened that 2 Nobel Prize winners served me as a porter. I was really ashamed. I was about 29 years old at that time. So this trip was a great success. I lectured. I have some. Shall I show you?
Okay.
This is the announcement of the lecture in see it? Goes there. And at Brown University and Princeton and Columbia, and the interest was really tremendous in heavy hydrogen. Now, I went back to Cambridge about 3 weeks later and continued this work. In the meantime, I I moved on into a better laboratory, more suited for the work I was doing, and I had a very elaborate gas system, high vacuum system, all blown of glass, mostly by myself. And in the same room was a young Scotsman, H.W. Melville. And we got very friendly, and we planned a number of experiments which were partly done in my apparatus and partly his, and our 2 apparatuses were connected with a big glass tubing, and we had a number of publications. And we decided that there are so many techniques on gas reactions that most people don't know, and you have to work it out yourself, that we write a book. And we wrote a book, Experimental Methods of Gas Reaction, which was published in 1939, I think. Yeah, 1939. Now, in 1936, I decided to visit my brother in Jerusalem, and he was very anxious that I should see him. He was already established and very happy. He worked also not only at the Hebrew University in Jerusalem, but an institute in Rehovot, about 50 miles from Jerusalem, and I visited him. Now, as it happened, this was a momentous occasion. Now, my wife, I hope she doesn't hear it, but I met her at this occasion in April 1936. And before I left Jerusalem to go home, I married her and lived happily ever after. This was a turning point in my life, because her father had a big house there and orange groves, and we thought maybe we should go back to Jerusalem from Cambridge and see how we like it. And that's what we did. We went back to Jerusalem, and I got a instructorship at the university, not with much salary, but we thought we'll try. Now, this was a big change. The living conditions were, I shouldn't say primitive, but we didn't have gas in our apartment. You had to use, everybody used a kerosene stove, but you had a help, a young girl used to come in for half a day or so. And we had a reasonably good apartment on the 5th floor of a big building in the downtown Jerusalem. Our son was born 3 years later in 1939 in Jerusalem. Now, at that time, clouds gathered over Europe, and everybody thought that the war will break out any minute. And sure enough, it did in September 39. Well, the situation, well, I should say something now right here. I mentioned his father had an orange grove, and they had a tremendous problem with the rotting of the fruit, because it took the small steamers, I don't know, maybe 4-6 weeks to carry the fruit from Palestine, it was then, to England. And by the time the fruit arrived in England, very often half of the fruit was all rotten by penicillium. And I read somewhere that diphenyl is a very potent retarder for the molds that grow. Well, to make a long story short, I worked out a method to impregnate the tissue paper in which each orange was wrapped at that time, to impregnate that paper with a small amount of diphenyl, which would stop the growth. We experimented with this, and it proved in small-scale experiment very effective. And then we persuaded the growers syndicate to try this on a large scale, and it worked. We could deliver the fruit with a minimum wastage if the fruit was wrapped in these impregnated wrappers. So they decided that this should be looked into more, and we went over to England and explained to authorities what we are going to do, and they said, of course they didn't know much about the effect of chemicals in small amounts, but they said they couldn't find any bad odor or taste or anything like that, and they agreed. So we started to ship fruit in these wrappers, and it was a great success, and it was published in a magazine, several scientific articles appeared, and I got an invitation to come to the USA to make a large-scale test in the United States. This was in 1941, and we decided we'll try that. And we left in October, and it was a long voyage, because the boat had to go all around the Cape from Egypt. It took 60 days to get there. We were quite comfortable, but it was a dangerous trip, but we arrived safely. We stopped in, I don't know how many ports before we get finally to Jersey City. And well, I don't have to tell you, but before the year was out, the war broke out. We were at my brother-in-law's house in Johnstown, Pennsylvania, when we heard that Pearl Harbor was bombed. And then I thought, well, I'm not going to back. We can't go back to Israel, and certainly not while the war is on. And I was visiting a laboratory in Ontario, in California, where I heard that from a Hungarian doctor we had mutual friends, and he said, you know, I know the director of research of Union Oil Company. If you want to stay here, why don't you try to get a job there? So the company that I worked with about the orange paper wasn't definite. I didn't say yes, I didn't say no. So the following week I went to the Los Angeles office of the Union Oil Company, and I said I would like to apply for a job. And they said, why don't you write to the director of research? And I did that, and I didn't have much trouble. I got the job. Now, what I forgot to tell you, when I left, just about this time, I got a message from my brother that Szilard, Abba mentioned then Szilard, he says he's very interested in heavy water and write up every method that we worked on and that you can think of and send it to him. He will forward the stuff to Professor Yuri, who is in charge of this research. Now, by that time, I knew what this was all about, because a couple of years before Szilard propounded this idea to use I didn't know that how heavy water was involved, but they used heavy water as a neutron moderator, even in those days, and I thought this is what he's interested in. So I sent him the information, and I got back a letter eventually from Professor Yuri, which was stamped with a secrecy stamp, and said that this material is protected by the so-and-so Treason Act, and any disclosure of this material will be punishable by law. So I knew what this was. Now, we got back to Union Oil Company. I got a job without too much trouble. This Don Carr was very friendly, and I was considered sort of a theoretical chemist, because probably I knew more about physical chemistry than the other chemists. They are mostly engineers. And I started to work on aromatic hydrocarbons, conversion of petroleum hydrocarbons into aromatics, and I had to also look up ways to make butadiene for the synthetic rubber program. But one day, Don Carr asked me, he said, I would like to talk to you. I said, come to my office. So I came to his office, and he said, you know, a young professor in California asked me to let him have one of his schoolmates who works in our lubrication laboratory. I forgot his name. And he says that this young man, whose name is Seaborg, has some idea that would change the whole outcome of the world. What do you think this is? Well, I said, I have an idea what this is, because Seaborg wrote a chemical review on artificial radioactivity and transformation. You know, by that time, in the end of 40, they had several ways to cause radioactivity, convert one atom into another with or without neutron emission or X-ray emission and on. And he mentioned at the end of that article that if you can have a sustained reaction in which you introduce one neutron in an atom and two come out, that you have a chain reaction which can, and each neutron releases a tremendous amount of energy at the loss of a minimal amount of matter. You can produce a very powerful bomb. I said, this is what they are working on, I think. So, and so he said, okay. He says, a few days later he said, you know, I called up Professor Millikan. You know, he was the president or past president of Caltech. You know, that is the Millikan who discovered or measured the charge of the electron 50 or 60 years before. And Millikan told me, he said, that it's impossible, not a chance. So I said maybe he doesn't know about this possibility, or he didn't want to tell you. This is official secret. But he let this man go, and you know what happened. I heard from others later. This was in the beginning of 42. A few years later, 43. There were some mutterings, you know, but people who visited the laboratory and in Los Alamos and were in on it without saying what it is and how it's done, but that they were working on the atomic bomb. So, so old Szilard, who dreamed this up many years before, was right, but poor thing, he didn't get a good treatment. But mainly because it's his own fault, because he was very aggressive, and if he wanted to, he would walk through everybody, you know. And he thought, even when the atomic bomb project was in full force, that the scientists should have the ultimate word, what should be done or when it should be used, which is of course impossible. And this General Groves, who was in charge of the Manhattan Project, was furious with him, and he wouldn't. He just a few months before the atomic power went critical, you know, in Chicago University, and all the scientists who were involved, Fermi and Szilard and all the others, were very excited. He made the ruling that Szilard is out. They shouldn't even let him be present at that occasion. And the scientists said, then we'll quit too, you know, and he had to rescind it. But he was really a persona non grata in official circles. But I think everybody agrees that he was the most ingenious person, who had more ideas than any 10 scientists, and he was ahead of anybody years. He saw ahead, and he was not a very good experimentalist, because he had no patience. He had such a drive, he couldn't stick to anything. He wanted other people to do exactly what he wanted. Unfortunately, he got to a bad end. First he had cancer, and then he got over that, and then he suddenly died a few years, but relatively young, yeah. Can we take a break?
Okay.
For him, he decided he will work for his PhD. He was a smart, and he was a chemical engineer, pretty good. And he got some help. Actually, he worked on such a government job, you know, but on the side, he could also somehow work on his regular PhD thesis, which was eventually published.
Do you know how Krieger got interested in government research, or was it just something gradual, or he never talked about it?
Well, I'm sure he was approached. I mean, that he didn't. I don't think he went after it. Or, I don't think so. Well, I'm sure a lot of professors did similar work.
Do you know how he managed research in the laboratory, or what type of a person he was in handling graduate students?
I'm sure he was a good boss and a very agreeable person to everybody, very polite, and he got along with everybody very well. I thought I talked to Weiss, and he was very pleased. He thought he's the nicest professor he ever had. We were shocked when we heard that he had a heart attack. He had a boat, and they went out, his wife and somebody else, and I guess that's strange because you have to work on a boat. But besides that, anyway, you can have a heart attack anytime.
How about Grosse?
Well, he was I think he was a real interesting person. Originally, he had some very good ideas. You know, he was also involved in radioactive research, and let's see, I think in the atom bomb he was involved. But in later years he sort of faded. I was pretty old. He was the president of the Temple Research Institute. And then somehow I think he didn't keep up with the times. That he didn't do so well. He had some outlandish schemes. One was how to control bombs, and that demonstration. One idea was to have a plastic foam. You blow plastic foam on them, and they sort of it stops because it sets, and you can't get the. I never saw that plastic foam in action, but I would certainly run away if they would try it on me. Then he had some other schemes to build on the same kind of principle, build various structures and a canopy for plantation in the desert to protect it from evaporation and so forth. Acres and acres covered with some plastic film. I don't think he did anything. He got away from the area what he really knew. But he used to come to the Gibson or Gordon conferences for a while, but then he really didn't have much to say because sort of he got out of catalysis. And I lost touch with him. I came across one of his schemes in my old file. It was too fantastic to keep, so I just threw them away. It didn't work, but he had a lot of publicity. He was a good promoter. He got in the Wall Street Journal and other journals, sensational inventions, which had nothing to do with catalysis, some concept, outlandish concept that he thought of. He also had to blow big plastic bubbles.
he came up with these ideas himself, or he had a
I don't
sort of
know
a think
who
tank?
I think he came up by himself. I never understood why he didn't stick to his original concept, although he had some weird ideas about catalysts. I think there was one idea that the cracking catalyst is really inactive, and it's only activated by the coke deposit. And I know that somebody even made a little verse about about this discussion, or what the people said about this theory. It was very funny. I wish I had it.
Can you think of any other weird ideas that you've come across in catalysis?
Well, let's see. Well, I don't remember what this was about, and I was the editor of the first International Catalysis Congress in '56, and I was also the program chair. And all the papers came to me, and I had to look through first at whether they were in good shape. If they were in good shape and made some kind of a sense, then we send it out to the reviewers. But you should have seen what kind of papers, because one paper didn't make any sense whatsoever. This guy wrote that for 20 years I have been trying to publish this paper, but nobody wanted to publish it. And apparently they don't appreciate what I'm doing. So I wrote back to him, but I tell you, many of us feels the same way, but we will submit it to the reviewers and see what happens. Of course, they turned it down because it was absolute nonsense. That some paper came to me that was really just scribbled all over the place. I'm sorry to say, some very prominent people that they should know otherwise. And my son was about 15, and he was good in English. He didn't know anything about catalysis. But then I enlisted him to help me put this in a printable form, because you had to have an abstract and the title and everything to be set up so that the printer could read it. And it was a very arduous work, because I don't know how many people. It's a fat volume of the advances of catalysis. I don't know how many 100 pages, but it was a tremendous job. But my bonus was I got all sorts of foreign stamps, in big fat envelopes, lots of stamps for Siam, and I don't know, all over. I collected all those stamps. So I have a good stamp collection. But there are always some weirdos who come up with some ideas. Well, some great people have also some weird ideas. What can you do? We have some papers in there which are questionable value. When people go out of their field, out of straight catalysis, and then have some other ideas in other fields, apply catalysis to medicine or to economics and so forth, and it can be pretty rough.
What is the difference between someone excelling in research and in, let's say, organization? Can the same type personality do both?
Well, I guess he has to have some organizing ability, at least for his own work, for his associates, because if you, especially if you want to complete an invention or a new process and make it practically useful. Because if you have just an idea and one or two experiments, you can never sell it. And I can give you a good example. We came across at Hoodry, the objective was to make chemicals and use the catalytic methods that they developed for petroleum refining. And one idea was, you know, the dual function catalyst that has an acid function and dehydrogenating, hydrogenating activity. So these two functions, if they work together, they can convert cyclic, cyclopentanes, cyclohexane into aromatic hydrocarbons, and isomerization and aromatization at the same time. So one idea was to make piperazine, because Hoodry learned that piperazine is an important chemical. This is like a benzene ring, but there are two nitrogens. So they tried this, and they did get piperazine, but they also get a lot of other amines from ethylene diamine that condenses and splits off ammonia. And in this mess, which was maybe 10 or 20% piperazine, there were 80% other mixed chemicals. And these were saved in big barrels. And one of the chemists named Herrick found that there was some crystalline material that separated of this mess. And while piperazine is crystalline too, this was different. It had a much higher melting point. And they analyzed it, and based on the mass spectrographic data, they came to the conclusion it was vinyl piperazine, or at least corresponded to the formula. But then later analysis and more studies showed that it wasn't vinyl piperazine, it was a cage-like compound with piperazine, like piperazine, but there was another bridge across the two nitrogens, so that it was like a cage. It was, the official name was either triethylene diamine, amine connected with three ethylene groups, or diaza bicyclooctane with a bicyclic ring with two nitrogens at the bottom. Now, it was an interesting substance, not a new substance. It was known for about 100 years when this was first discovered in that mass. But it was done by a complicated synthesis, stepwise synthesis by an Austrian chemist from Matka. And then Orchin was our consultant, and he suggested this, if this is diaza bicyclooctane, it was an amine, a tertiary amine, which had no steric hindrance, because the carbon chains were sort of tied back, and the nitrogen of both ends were exposed. So he said maybe they would work on polyurethane, which is made by reacting an isocyanate, or rather a polyisocyanate with a polyol, and that's how the rings, the chains go. And he was connected with an outfit, I don't remember, in Cincinnati, working on oil. Will come to me in a moment. But anyway, they made experiments with isocyanate reaction with certain amines, or certain alcohols. And they tried this substance, and it worked very, very well. So we got all excited. But that isocyanate that this firm started to, or rather that urethane, what this firm started to, or tried to promote, didn't get off the ground. The isocyanate system, or polyurethane system that was of commercial interest was from toluene diisocyanate and a chain, a polyglycol. Well, we tried it with that, and with certain modifications of the regular recipe, it worked with that too, and that was really a big success. And somehow our sales department, in a brainstorm, decided that they are going to sell this material for $10 a pound. And we said, $10? Nobody will pay for that. But they did, because it was really good. And this went off like a skyrocket. And we had a problem how to make it and how to purify it. Well, that was a big problem to recover it, or recover it efficiently from a mix, or improve the yield, purify it. You couldn't. It was very difficult to distill it, because it was the melting point and the boiling point were very close. So you couldn't cool it because it clogged up the condenser. And you couldn't separate it too well with piperazine, although the two boiling points were very different. They still co-distilled, the sort of formed an azeotropic mixture. So this, to solve all these problems before we could really, and to purify it to a certain standard specification, it was really a big job, and we did it gradually, and it took a long time before we did it. And I think if somebody would have stopped at the early stage, this would have been a dead project. But it was very successful. I think this happened almost 30 years ago, and I think it's still a leading polyurethane catalyst. And this catalyst is made by a catalytic process of its own, where we used a catalyst which is very similar to the cracking catalyst that they are using in petroleum refining. And this needed a lot of organization between the laboratory and the pilot plant and the factory and the testing, the outfit that tested the product, and one outfit or one group made the polyurethane foam on the foam machine. It was really a complicated process before it was ready for large-scale commercial use.
There's a person at Hoodry that was there, I assume, when you were there, Wheeler.
Yes.
How would you describe him?
Well, I think he was a brilliant guy, but I think he had problems. Well, I'd rather not talk about it. I mean, he was a nice fellow, but he had a lot of problems. Some of he was not responsible, and for some other he was. So he left. He left. He left his family, and he left suddenly. I think somehow he recovered. I don't know what happened.
To go back to Allied, you told how you decided to come there, but then we got off on something else. You want to go into some detail about the Barrett division?
Well, we had a very autocratic director who hired me, and he was very polite with me. He treated me well, except if he gave me a fairly good salary, but he left it there. He didn't believe in promotions or during. That was in, let's see, that was not during. That was just after the war in '46, and I started in a small laboratory, but he gave me a bigger laboratory and a bigger personnel, and I was quite happy with it. Except, as I said, they didn't reward you. I didn't raise your salary for about 5 years, as I remember. And he didn't raise anybody's no, nobody protested. But we had good working conditions. He was a good chemist. He would sit in his office, which was on Rector Street in New York, and studied chemical abstracts and chemistry books all night till he understood what we were talking about. And he was very anxious to accomplish something, but he had some very drastic methods. He would have meetings in his office, and it didn't matter with everybody, all the personnel from the different laboratories there, and he would scold anybody before the rest of the group. He had no compunction about that. And I don't know how he got away with it. People were maybe afraid to leave or contradict him. But as I said, he treated me very, very well. And years later, I happened to be in his office, which was a big library. No, I should say that I went to the office there, and I wanted to look up something in the chemical abstracts, and they told me that the chemical abstract used to be in the director's office, but now they are in the library. And I saw there was a little marker in about dozens of chemical abstracts. So just for fun, I opened it up, and on that page, you recognize your name without looking through it. There were maybe 50 entries in those two pages, and my name was on an article, and there was a little mark there. So what does it mean? Then I took out the next volume, and ditto. It was so obviously when I came, I applied for a job, or he looked me up. He looked up all the papers, that I published. That's the kind of guy. And he forgot. He left all these markers there, and it was this big stack at least 20 or 30 these markers. And later I asked a fellow who was instrumental in getting in touch with him. I said, "What does this mean?" Oh, he said, "Oh yes, that's what he did. He looked up all your records, and then he was satisfied, because he didn't want to write to any of your references that you mentioned, among which I mentioned Yuri, because he was afraid that if Yuri or these people find out that you are looking for a new job, they will take you and he won't get you." You remember that novel, The Hustler, by, that was, you probably won't, but there is a character described who was a boss, a company president, who acted almost exactly like this director, with very drastic or I should say rude behavior to draw attention to whatever he wanted to accomplish. I get along with him. One of his famous stories was that he found out that coal tar was dangerous and might cause cancer. So he went to a specialist and asked him about that. How does it show up and so forth? What should they watch out? And he looked at the director and said, "No, wait a minute." And he looked at him closer and he said, "You know you have skin cancer." And he got scared first, but you know you can operate that. And we got all right, we got well. But he left, I don't know, he must have been 70 years old. That was way behind, over retirement age in those days. But he was still kicking another 10 years later because we had an old draftsman who was hired by this director, and he saw him occasionally, and he said he's still alive and kicking. He was a great guy. Barrett was, and Allied was a curious company. I think I was told they were run by bankers, who didn't want a big profit. If they made 3% on their investment, they were satisfied, and they were afraid of any innovation or progress or anything like that. And they had Allied was founded in the 20s by I forgot his name, but a strange guy who ordered, the first order was that they should use only typewriters which have capital letters, but indicate lowercase, they have big capitals and low capitals. So all that, have you seen that? Have you ever seen that? Let's say something. And all our typewriters, I have reams of material which was typed on that typewriter. This he ordered in 1920. 25 years or 30 years later, they still adhered to his orders. He was long dead by that time and out of the business. And another thing was they had Allied had several divisions, almost the Barrett division. There was the National division, and there was the Nitrogen division, and there was the Solvay division, and they worked on major chemicals like Barrett worked on coal tar, National Handling worked on dyes, but they also worked on phthalic anhydride. So in certain fields that different divisions overlapped, and you never knew which division would get the job, but apparently it was I thought it was a silly idea to have two divisions working on it, and then the management will decide which got the better process without interchanging information, and then they picked that one. I think it was very wasteful. We worked once on formaldehyde process, and once we worked on ethylene oxide and maleic anhydride, and they gave it to some other division. I mean, I'm not sure that it was better. It was just a management decision who gets it. We worked on a very large number of processes. I think I mentioned the cumene hydroperoxide. That was done by the Central Research in Morristown, which was a very good group. First they worked in a abandoned garage, but then they bought a great, beautiful estate in Morristown and had built a laboratory, and eventually they transferred most of the laboratories over there into Morristown in a gorgeous campus-like arrangement, and also some of the offices, I think. A lot of people who worked at Glenolden were transferred over to Morristown, which was a nice move because it was a wonderful place, brand new everything, in a gorgeous estate.
How did you end up going to Hoodry then?
Oh, Woodley. Well, this was also a strange thing. Barrett got in the plastics business. They bought Plascon, which made plastics in Toledo, a relatively small company. They made, I forgot, alkyd resins or resins for extrusion and so forth, films and so. And they had a director there who came along and became our director. They combined the research laboratories of Plascon and Barrett. So Barrett became the plastic division, you see. And this guy from the new company came to Glenolden, where our laboratory was. And he was really, I won't even mention his name, an SOB. You want to hear a story?
Yes.
He said he was on one of the teams that went over to Germany after the war to interrogate the German scientists and industrial chemists, about these different processes. Germany was creating those processes in synthetic gas or gasoline and various acetylene chemistry and oxidation chemistry. And the Germans did a tremendous amount. Have you ever, those volumes about this data that they collected were really tremendous. So he says he was colonel, and he was supposed to interrogate a famous professor whose name escaped me. As most names escape me. I can look it up. And I don't even want to mention names. But he said he interrogated this professor, and the professor wasn't straightforward. In other words, he didn't open all his books and give it in everything. So I kept on asking him and asked him. And then he said he still wasn't forthcoming. He said, then I took out my revolver and I put it on the table and said, well, I'm asking you once more. And then he opened up his and he told about all the catalysts he used. Well, I believe he really did that, because he was that kind of a guy. That was one of the reasons that I left, because I just couldn't stand this guy. For example, you know what he said? Once we had a meeting, and one of the chemists, a woman, got up and went out and came back a little while. So this SOB asked, Miss, you couldn't wait any longer. You couldn't hold it a little. Can you believe that? I mean, that was one reason. And the other reason is because they offered me a good increase. It was a mistake because I should have stayed on a little longer. It would have been to my benefit. But I just couldn't stand this guy. And I enjoyed I knew all the Hoodry people, and I got along very well with them. And I think we did a good job, because we really got this chemistry project going. They really had no familiarity with industrial chemicals at Hoodry, but we really got it going. few products, and then this polyurethane and other chemicals and auxiliary chemicals became a real big thing. They bought some vinyl plants. And then Air Products took over Woodry in around 1962, thereabouts. And they really took off because it became a part of Air Products. That was a new chapter in Woodry because it was again a new management and a new point of view. They were more interested in processes and chemicals than, products and chemicals than catalyst. Catalyst is really a real small amount, a small part of the profit. Because the catalyst costs 1 cent, and what you make costs maybe $1. So they were interested in more product and more polymers, plastics, and the polyurethane and the Depco and other foam stabilizers and other viscosity improvers, etc., etc. It became a very big business.
How do you recall Eugene Houdry?
Well, I didn't have really too much contact with them because by the time I joined, he was I don't think he had he managed the company actively anymore. He may have had some shares, but he had no majority interest. But I only met him in connection with that first catalysis conference. And, he was asked as an honorary vice president or president of the catalysis congress to give a speech. And then he sort of talked to me what he should say, and I went to told him in general terms what we expected to him. It was more or less what he did during his life, how he got into the catalyst business, the petroleum cracking business and other. But we had really 2 or 3 projects. One was the cracking catalyst, and the other was the butane dehydrogenation to make butadiene for synthetic rubber, and the third was pollution control. These were three ideas which were very important, and 2 of them were very successful. And the catalytic cracking process developed from the idea that we found that certain clays, the petroleum over a clays at high temperature, they will improve the characteristics of the catalyst, the performance of the gas oil. The only trouble was that the catalyst soon got clogged up with coke and lost its activity. So he said, well, what we do, we'll have to burn the coke off and see if it works. And then he found out gradually that if he burns it off at a relatively low temperature, then it will be reactivated. Then he worked out a process that he had three reactors, and one was operating, the other was being purged, and then the third was regenerated, and maybe a fourth was cooling off, you see, and then they changed it around and operated first the one and then the other and so forth. It was pretty complicated, but it worked. And he had a process, another process, I think, where the catalyst moved gradually through a kiln, and the Felbin more at the top. Well, these processes worked pretty well, and it was an innovation. And then he wanted to sell it to the other companies. And he apparently asked too much money from Esso. The Esso said, "Oh, heck with you. This is too complicated anyway." And then they developed a fluid process, which is really a good process. But a number of companies bought this. Sun Oil among them. They are big moving bed catalysts. And it was a good process. He made a lot of money of this, and Woodley flourished with this. They had a lot of customers and catalysts. They sold the catalysts, but it didn't conquer the whole world. But the dehydrogenation process, which was similar, it was a different catalyst. And again, the catalyst was coked up. It was a chromia catalyst. But they burned it off and then switched the valves over so that the fresh regenerated and they operated again. And this persisted, and this was a good process, and they sent a lot of these processes and catalysts to make butadiene. So that was I would say, 100% success. And the third, the pollution control, he had a good idea. He made a ceramic honeycomb from little rods, which were ceramic, slightly porous, and put on a alumina coating and then platinum, a thin coating. And if you blew a contaminated stream with odorous substances or fumes or anything, at a sufficiently high temperature, this ignited and the temperature got even higher, and all the impurities and pollutants were burnt up. And then it worked very well. It wasn't good enough for the automobile because it would be too big, you see, too bulky. It would take half the car, space of the car. But it was okay for small car to have a combustion engine like a tractor or a lift truck or something like that. And it was installed. It was also good for factories who emitted some bad smelling or obnoxious chemical containing fuel. And they were used. And anyway, this was a great innovation. Nobody thought of this before him.
Now, did he make what were the ideas on how to solve the problems coming up primarily his, or was this a team effort?
Well, his original idea was his. All these three ideas, as far as I can tell, were his original idea. And then he had the people work the fingers to the bone to solve the problems, the execution. But I think he was a good leader, although a very, very strict person. He wanted the people to work real hard and be there after 5 o'clock, it was necessary. And keep on working on holidays, Sunday, any time. Well, some of it was during or right after the war. Let's see, is that well, not really. It was. This development was in the early 30s. It was just before the war. But he was a strict taskmaster, as I heard. I never knew him in that capacity. But he was a very nice gentleman. Once I traveled with him on a plane. He and one of his helpers, or I think it was his brother-in-law who was with him. And I talked a few words with him. He's a nice gentleman. He gave a pretty good speech, but it was sort of old-fashioned. I mean, it wasn't in the new catalytic sense, new principles that the catalysis is a scientific discipline. I think what he was pre-scientific concepts. But I think he was a good man. He was an engineer. He wanted results. He didn't care how you got them. But at Hoodry they developed Oblad, Mills, and these guys. They figured out how the cracking works, the mechanism, the hydrogen, the theory of the catalysis, that it's a proton transfer under the acidic radical, how it decomposes, and also how the cracking, how the dehydrogenation catalyst works and so forth. So Hoodry people were very good, and they had a good name, and everybody was interested in their work. There was again a small group of people that were very efficient. I mean, way out of proportion of their size.
I don't want to jump around, but I wanted to get your impression of Hungary when you were a young boy. How do you remember Hungary then?
Well, I can tell you how we lived. I think I mentioned that I was born in a small place, but soon thereafter my father, who was a pharmacist, moved into a bigger town in the eastern part of Hungary, about 100 miles from Budapest. It's a nice town. It wasn't a very big town, maybe 100,000 inhabitants. And he had a pharmacy first, and he had built a brand new house not very far from the pharmacy. And we had a very comfortable house. We were 3 boys, and we had a room, and we had a German governess till we almost grew up. We learned German, and we had a cook and a maid and a beautiful garden, and we had a really good time. And I think we walked to this grammar school. Yes, I think so. It was. We didn't use a bicycle, although we had a bicycle. This was we grew up during the First World War. And I remember we had bicycles, the older boys, but they couldn't make a bicycle small enough for our little brother. And then there was a mechanic who took a larger bicycle and just could cut out pieces of it and made a small bicycle for my little brother, so he could ride around. And then my father sold his pharmacy, and he got what they called a drugstore, but the drugstore in Hungary was different. It was like a pharmacy and perfumery, and also they sold health products. and it was really a pharmacy. They were not supposed to sell prescription drugs. You know, the prescription drugs were mostly they were made up in the pharmacy. You didn't get all the pills ready like you get now. Some of the prescription that the pharmacist had to take, need so much, mix it, make it into a pill or powder or whatever. So that they didn't do in this drugstore, but they did everything else. So, and he also sold on wholesale to smaller pharmacies in the neighborhood. So he did quite well, and we moved into a bigger home closer to the pharmacy with the drugstore, which was on the main street. And we had a very happy life. We went to this gymnasium, which was very close. We could walk there, and we played tennis and swim. We had a river where we swam, and swimming. They called it it wasn't a swimming pool because it was just a sort of a framework which was in the river. You know, the river flew through that woodwork. There was walk around the middle, and you could swim from one step to the other, then you could get out and walk back and swim to, or you could swim against the stream, which we did if the stream wasn't too strong. And we took fencing lessons, and what else? French lessons, English lessons, everything at the school. So we had a very, very nice life. Never missed anything, even during the war. We had maybe a few days, meatless days, but there was plenty of food. We never had any problem. But the problem was when the war ended, and Romania, that part of Hungary was ceded to Romania. That was a very unpleasant because the Romanians wanted to abandon the Hungarian language, and people who didn't pledge allegiance to Romania were discharged. Attorneys couldn't practice, and officials were fired. So it was very unpleasant. It didn't affect us too much, but it was difficult. And then I think I mentioned that when we my father finished the school, but the high school, and then he went off to Berlin. But by the time I got to that stage, our school was closed because the Romanians said that this Catholic order had some subversive activities, and they can't teach them anymore. They teach us anymore. So that was one problem. The other problem, there were demonstrations against the Hungarians. Some students demonstrated against the Hungarian stores, and especially the Jewish stores. They broke the windows and so forth. But that we got over. Then the real trouble started when 10 years later, when the Nazis and the war broke out. I don't know how to speak. But our youth was very pleasant. I can't remember any problems. Only had fun and enjoyment. We had first we had stoves in each room, you know, made of ceramic, big stove. But then it changed over to central heating, and we had with radiators, and we had as soon as the frigidaire was available, we had that. We had, of course, running water, and very, very comfortable house. Large home.
Did you attend schools that were just boys, or was it mixed?
It was only boys. At the higher grades, they allowed the girls, if they wanted to attend that school, they could only be what they called the private students. They were subjected to the same tests, but they didn't attend the classes except physics and chemistry, I think they were, because they needed demonstrations or the laboratory work or something. They were allowed to come, but there were only a very few girls who attended. In those days, they didn't think that the girls need university education. Although they were girls' schools, but not within this Catholic order. Although those priests were very, very liberal, you know. They at school they wear a robe, but they used to walk on the main street where everybody promenaded, you know, in the afternoon or the morning. And the priests used to walk in civilian clothes. I mean, if you didn't know they were priests, you couldn't tell them. And even with some ladies, they would walk. And they went to the theater. We used to go to the theater. My father had a box. They went to the theater almost every month or every other week, and we went to. When we grew up, we went with them. And the teachers we saw in the other low box or on the floor, they went to these musicals and plays, and nobody thought anything about it. There were also even some scandals that one girl, one priest would fall in love with one lady, and she left the order and married her and lived happily ever after. But on the whole, they were very, very liberal, and nobody questioned what they are doing or not doing. In other words, they don't live like monks in that big. They had a tremendous big house there. Each priest had one or two rooms. I think 2 rooms. And the walls. I think that it was a monastery originally, but they turned into school. The walls were maybe 3 or 4 feet thick, mason. And it was really some building. And they had one big classroom for each grade, and separate rooms for drawing and physics and chemistry and so forth. It was a good school.
What was the attitude during and after the war with the treaty? What was the Treaty of Triton?
Trianon. Well, they divided the Austro-Hungarian Empire. Hungary lost a tremendous area because it was a conglomerate of several states or languages, you know, they were Hungary, in the proper Hungary, which was like a half moon, like this. There were Hungarians in the middle, and there were Romanians in the east. There were Germans on the west. There were Czechs and Slovaks up north. There were Croats in the south, and Serbs and Yugoslavs, and a lot of nations, you know, and they were all unhappy with the foreign rule. So they were all carved off, and including some of the Hungarians. You know, you can't separate the Hungarian, German, or Romanian. In our neighborhood, in our city, there were no Romanians. There were Romanians in the villages, maybe 20 or 30 miles away. But then 100 miles away, there was again a city. It was practically 100% Hungarian, but they took a whole works, everything became Romanian. Then after the Second World War was over in 1940, I think it 40. Yeah, I think it was 40 when in that part war. No, that wasn't 19. A few years later, it was over. Then some of the our city was returned to Hungary. But I don't think for good, because later it was taken back by Romania. So it was pretty rough at that time.
Do you recall the short communist government, or were you young?
Very, very briefly. That I was, let's see, that was in 19. I was a young boy. I knew about it. In fact, my father, who used to travel to Budapest on business, and he had a sister there with him. Once he came back and he told us a horror story that they arrested him. They were looking for a similar, a guy who had the same name as he, and he was somehow involved in communism or in something. And he had a heck of a time proving them who he was before they let him go. No, it was pretty bad at that time. When that was when Horthy came in. That was an anti-Semitic regime. You see, they said that all the communists were the Jews and all Jews were communists, which was far from true, because all the people who had something hated nothing more than communism. It was, they were called the rising Hungarian, rising meaning that they awakening Hungarians. Their sign was a arrow cross, not a Haken cross, arrow, an arrow. I don't know whether I told you this story when I was at this Faraday meeting. They had the Faraday Society meeting in 1932. They had this dinner for the foreign visitors, and it was pretty formal. They gave a toast to the king. The king King George, and then in turn they wanted to greet all our kings or presidents or whatever. Yeah. So that they drank a toast to the president. Let's see, who was it? Roosevelt, 32.
Yes.
Then they drank to the president of the French Republic. Then they drank in my honor to Admiral Horthy, the leader of Hungary. Hitler was not. Hindenburg, I think, was the president in 1932. Field Marshal Hindenburg. For Dr. Magnus. Strange.
Now, was in England, did you encounter the same prejudice, or was England much?
No.
Did you meet Donnan?
Who, Donnan?
Uh-huh.
Yes, I mean, he was at its dinner. In fact, he was very, very helpful in this whole effort, to place the displaced scientist. He was one of, in fact, I think he even went to Paris and looked us up originally. I don't remember now, really. But he was very active. He was sort of semi-retired. He was at University College at that time. I don't think he was very active. But he was a very fine man. If I come to think back, that was really a terrible situation. Imagine all these people let go at once, and they were chased away from their own country. Most of them were German. Where would they go? How can they find a job in a foreign country, not knowing the language? So,
how would you describe the atmosphere of Berlin when you were there?
Well, before Hitler, it was, I mean, we didn't notice anything. I mean, in 28, it was very free, and you could buy anything. The theaters, movies were all very good and interesting, and these cabarets, where you go for a drink and they make jokes and sketches, like you see on Johnny Carson, political caricatures. There were lots of fun. I mean, dancing. It was very pleasant. You could,
have you been back to Berlin since
No,
it was built up?
No, I really didn't even, I wasn't too anxious ever to go back, because it just brings horrible memories, what went on. I was very happy there. My brother was up to that point.
Now, most brothers have a hard time getting along. In that way, you were very unusual.
We really got along very, very well. We had often one bank account, and we never quarreled about money or about anything. We, for a number of years we lived together, but we never had any problems with that. We never had any arguments about who should do what or publication, work. I don't know, we always got along well. I know brothers and sisters quarrels, but we never quarreled. I don't know why, maybe it was our parents' influence. We were very happy.
Were you and he alike or opposites, or
What? But,
personality-wise?
well, we were a little different, but we got along. I think I was more, what shall I say, a little less studious than my brother. He was more a student and a harder student. And, so I think I mentioned he was more interested in mathematics and physics. I didn't want to go that deep. But, otherwise we had similar interests. We played tennis together. We went to what else? We did everything together. We had, both of us had lessons, language lessons, and we got along together very well.
When he went to Palestine, it wasn't like going to Palestine going to Israel today.
Well, that was still under British
Mhm.
mandate, but there were still frictions with, to say the least, with the Arabs, because they didn't want the Jews there, and they used to come and make trouble. So even in '36. I had to go out for what they call watch at night with some other young men, and we took turn and patrolled the area where we lived, to see that no Arab comes there and tries to do some harm or some mischief.
Now this was armed?
Oh yeah, we had the arms, but it was sort of unofficial army. The British government knew that we had arms, and but they looked the other way. They knew what the situation was. The Jews didn't invade the Arabs' land and try to kill people or bomb or burn. They never. Although some Jews said, "Look, you know what we should do? That's what we should do, because that's what they understand." See, they don't understand. You can't persuade them what's good. And the British did that. You see, they started this blowing up of the houses for people who were suspected of rioting and shooting at the British. They made these rules. And now the Israelis take advantage of those rules, that they were original British rules. The British were very, very strict with all that. They didn't stand for any nonsense.
But even at that time...
This was before the partition of Palestine. When the British were in, they had trouble with the Arabs, because they wanted to get off the British, and they also had some trouble with the Jews, because the Jews wanted to bring in more immigrants. All the displaced people from Germany and all Eastern Europe, where they had nowhere to go. They wanted to bring them to Palestine, to the Jewish part. And then finally there was a British commission that studied the situation, and they divided Palestine. Said this will go to the Jewish portion, and this will go to the Israeli portion. And everybody had to agree, because the British said we are leaving. You remember that during the First World War, Weizmann, who was a chemist, did some wonderful work for the government, developed some explosives and solvents for explosives, and he was asked, well, what do you want? You want a knighthood or lordship? You choose. And he said he doesn't want any honor of that kind, but he wants a land for his people, the Jews. And the government gave them part of Palestine, or promised them during the war. If we win the war, you can have you can have a homeland in Palestine. That's how this whole controversy started. Although by that time there were some Jewish settlements in Palestine. And then you see the Arabs were not satisfied with what they got. But immediately when the Arabs, when the British government moved out and the Jews were on their own, I think it was in 47, 45. They all attacked Israel from every side, Egypt and Jordan and it wasn't Iraq, it was Syria. And they all ganged up on Israel. Israel beat them. I don't know how they did that. They won, and the Arabs were told that if the Israelis win, then you have to all leave, because they will kill every one of you. And they left. So the Jews took their land over. They didn't stay on. They left. You see. Then after they won, they were beaten. Then they start all over again every time. And what they want is they try to win it by force. And if they lose, then they still want to have a chance to not to be treated as a conquered, as if they had lost their war, but they have to be given another chance. Well, I don't think that's fair. Hungary lost half of their country because they were on the wrong side in the war.
Now, did you live in a commune when you were there, or the equivalent of it?
We lived in Jerusalem. This was in the Jewish section, in an apartment house.
It was one large one.
Yeah, it was a large, a big apartment house for maybe 20 or 25 tenants. And it was fairly modern. Central heating, elevator, and everything.
Now, was your brother interested in politics, or did he just stick to science?
Well, he wasn't much interested in politics at that time. There really wasn't much. In fact, you see, Israel was, let's see, it was in 40s. That was barely exist. I don't think they barely declared the statehood. Maybe in 45. So it was just two years old when he was killed in the end of 38. But everybody is interested in politics. You have to be interested. That's a big problem. Do you know how many parties they have in Israel? I mean, it's really a joke. By the way, they had that in Germany too.
Yes.
The last election in Germany, I think there are over 30 parties. Can you believe that? And in Israel, they have 2 or 3 major parties and a number of minor parties. And the election comes out that none of the major parties has a good majority. They either have to form a coalition, but they take up one of these little parties to form a majority, you see, and they have such extravagant demands, those little, but they have maybe one or two members, this party in Congress, and they combine maybe 3 of these little parties, and then may have 10 members. But that would help one or the other of the major parties to form a majority. So they have a tremendous power, and they abuse that power. It's like blackmail. That's why they don't have a stable government. Why they have to have so many different parties is beyond me, and everybody is annoyed, and still this goes on almost every election. Well, you know what time it is? Yeah, you still have date.
Yeah, oh yes.